Okay, here we go. Semester exam fall 2019, part 3. We're going to get this done and we're going to try to get through this quickly and maybe we'll see what I can cover, okay? Alright, so let's look at these next ones. We're still continuing with the proving triangles. And I'll be honest, most of this is not as hard as this, but the idea here is to recognize what is side angle side or angle side and stuff like that. If I want to prove this is angle side, keep in mind, right now what I see is a side and an angle, okay? So I need another angle, preferably like somewhere before this side, because it can't, angle side angle would have had this one together with this one, okay? But again, keep in mind that they're asking, can I go ahead and prove this as it is? Well, don't forget, vertical angles are always congruent. So now I have angle, side. So yeah, that's true. Now keep in mind that for the next one, hey, this is a 90-degree angle right here. And so I want to prove this by, what else is needed to prove this by? Hypotenuse, leg theorem, the HL theorem. Okay, well, again, you've got a leg, you need the hypotenuse. So you need AE and EC, AE and CE to be congruent. And that will give it to you by HL because that would give you the H part of this. Okay, so again, can you recognize when you're using these? Alright, so again, what do we know about these two? These two are congruent because these sides are congruent. That means these angles are congruent. So here, x plus 12 is equal to 74. So then I subtract 12, and I get x is equal to 62 degrees. So find the value of x. Just find the value of x. So x is equal to 62. Alright. Let's talk about perpendicular bisectors and things like that. So again, this is where, just like the last one, just like on the last test, we talked about circumcenters and all that other stuff. Perpendicular bisectors, find xt, vu, and zv. Alright, so let's go back to that. So recall here that we had these circumcenters formed by perpendicular bisectors, and incenters which are formed by angle bisectors, and we know that these sides are all congruent, not to mention also the sides on the triangle. On an incenter, we knew that these were congruent, the ones that connect to the 90-degree angle. And also, let me go ahead and do it like this. These are congruent. These are congruent. Notice how I'm color coding this. The ones next to their congruent parts on a triangle. So these are congruent. Okay. So that should help us answer. And then this is again where we may have to use the Pythagorean Theorem, but I don't know if you need that so much on the exam, but I'll double check. Anyways, let's go back. So like here, I know that Vy is 15, xt is 16, this is 12, okay, 20, 20, and 20. So for this one, xt, we now know is 16. We know vu, v2u is 15 plus 15, which is 30. And then we have zv. And then zv is 20. So it didn't even need the Pythagorean theorem on this. Most of that was pretty easy, as long as you know the rules. And again, use the formula chart to help you with that. Okay, so on this one, we're going to do the angle bisectors, or we know it's the angle bisectors, so that's incenters. 42.6? Really? Alrighty. So you know this is 33 degrees and this is 33 degrees. So HJX. Okay, so how would I find the measurement? Okay, if that's 33 and that's 33, that means that's total is 66. So if I add 66 plus 78, 78 plus the 66, that would give me 14, carry that, 144, subtract that from 180, and you've got 36. Okay, so this whole thing right here is 36. Remember, divide it by 2, and that will give you like this, 18 and 18. So HJX, which would be 18 degrees. Okay, find the distance from X to GH. X to GH Okay, that's just a tricky question. I don't think I would be that tricky on a semester exam, but I'll double check. But again, x to gh would have been like something like this. And so that distance right there, let's say that's y. So xy here would be 42.6. Because remember, it's supposed to be equal distance from here to here. Like those are equal distance. And there you go. All right. So let's look at this next one. This next one is dealing with the the centroid, but let's talk about that. Okay, so remember, centroids are created by medians, and if we kind of remember this correctly, like how did I want to do this? Like how I did this before. Twice the short piece is equal to the long. Half the long is equal to the short, and the total divided by 3 is equal to the short. Okay, so I could use something like that, or the center. You just basically got to need to be able to recognize it and kind of go from there. So if I look back at this problem, I should easily recognize that these are medians, and if I know this is 6.1, then I can double that LZ, or I can find. Okay, so look, if I double this, I get 12.2. Add those two together, and that gives you 18.3. Okay, that would be LZ. So LZ would be 18.3. Okay, divide, like remember, you divide this by 3, you get 7.2. That would be WX right here, 7.2. Double that to get 14.4, and you got MW. So it's just a matter of easily recognizing and kind of going from there, and that shouldn't be too bad. So if you needed to see that a little bit larger, because apparently I didn't realize I had done that, again, double this, 12.2, add it together, that was 18.3. This was 21.6 divided by 3 gave me 7.2. That's right here. And then double that, 14.4, and that would give you the two answers you needed. Okay? Find AB. We do have a rule that says that if these are equal and it's a 90-degree angle, then these should be equal. So this should be 12.5 also. Plain and simple. I'm not going to go too far into that. If I needed to do a Pythagorean theorem, I would do Pythagorean theorem. Okay, 47. Let's talk about that one first. Okay, write an equation in point slope form for the perpendicular bisector of the segment with the endpoints 2, 4, and 6, 2. Okay, looking at the test, you can omit number 47. You're not going to get something like that, but you do need to know point slope form. And again, remember, that's y minus y1 is equal to slope, parentheses, x minus x1. So if I gave you something like this and said you have a slope of 2 and a point of 3, 4, then you can give me an equation that says y minus equals, parentheses, x minus, and you could go, okay, y with y, x with x, slope in the middle. And that's really all that is. I'm not, that one was a little bit more harder than necessary. Complete the sentence. The orthocenter is the point of concurrency of the lines containing the altitudes of the triangle. You should have that from your formula sheet. Helps if I can spell altitudes, but there you go. So again, some of this stuff should be easy and shouldn't be too difficult. So again, here we want to do, like say on number 49, we want to do a range. So to find the range, it's again, subtract the two numbers, add the two numbers, and you want something in between. So if you have 4 and 14 as your two numbers, you need to say 14 minus 4, which is 10, and 14 plus 4, which is 18. And that's the range that you would need for number 49, which in this case would have been J. Alright, use the figures, write the sides of FDD in order from largest to smallest. So let's go with this. Alright, so since these two angles both have to be acute, you know that this side has to be longer than these other two. So in order, FE is the smallest side, ED would be the next side, and FD would be the final side in order of largest to smallest. Now, if it was angles, keep in mind this. There's only one obtuse angle in a triangle. So this angle has to be larger than the other two. The smaller one, angle D would be the smallest one. Then it would be angle F, with angle E being the largest. And that should cover that. Now, if I want to compare these two triangles, and knowing that these sides are similar, like that, then I can look at this. And so FD has to be greater than GJ. And that's it. Plain and simple, right? I knew you could do it. Okay, so for the next one, what I went ahead and did was I went ahead and found the missing angle here. And then I said, alright, if I want to look at this, I added these two up first and subtracted from 180, and I got 75 degrees. So if I look at this, I know smallest angle is this one. That means that's the smallest side. Opposite. So KM is going to be the smallest side. Then the next one would be from the 68, KL, and then finally ML, in order from largest to smallest. As far as number 53 is concerned, yeah, we're not doing that. I'm not going to even worry about that. No. Alright, but you do need to know the hypotenuse and the right angles. Pythagorean Theorem type of thing. Have no idea why there's a smiley face. I have a feeling I should know, though. The hypotenuse and one leg of a right triangle. Okay, so again, like you look at number 54, and you need to look at it and say, alright, I can see this, and this should be 26 has got to be the hypotenuse, since they said this is the hypotenuse and a leg. So I can use this formula and say 26 squared minus 10 squared, which if you type that into the calculator and press enter should give you 24, and then you go from there. Numbers 55 and 56 are going to be special right triangles, which we will actually study next semester. So know your hypotenuse, know your Pythagorean theorem, and you can kind of go from there. Actually, that pretty much covers it. If I feel like there's anything in here, I'm kind of trying to look at the test right now. If there's like a question I feel like that we don't have on here, I'll go ahead and let you know, and we'll talk about it. But otherwise, that's it for today. Thank you so much for your time. Good luck on your semester exams. I'm sure y'all are studying very hard and trying to do your best. If y'all have any questions, make sure to ask in class. Y'all take care. Thank you so much. Take care.